looking at a question here that involves either the sine or cosine law. It's given in words, so we're going to have to kind of create our own diagram. So let's give it a read first. And as I read it, I'm going to underline or highlight the information that is relevant. So, from a boat on the water, the angle of elevation to the top of a cliff is 31 degrees. And angle of elevation is another key word here. I'm going to stop there. Okay, so I have water. I'll draw some water there. And I have my cliff, which I will draw as this. There we go. Again, very simplistic. Don't want to make it too fancy. And my boat is over here. Okay. The angle of elevation to the top of the cliff is 31 degrees. So if the boat is looking across, if that's the horizontal, then this will be my angle of elevation. Actually, let me do a broken line, okay, because solid lines will represent like a physical structure, and this is just kind of a line of vision. Now it says, from a point 20 meters closer to the cliff, the angle of elevation is 33 degrees. Find the height of the cliff. So the boat is now going to move 20 meters closer, and I'm going to try to represent that by moving the boat over here 20 meters closer. And now the angle of elevation to the top of the cliff, okay, is 33 degrees. So here it was 31. Here it is 33 degrees. The distance that it traveled along this line here was 20 meters. And this is a right angle, we'll assume. And I'll call h the height of my cliff. And that's what I want to figure out. Okay. I'm going to just simplify this by taking the boat out of the picture. I'm not going to delete it completely. I'm just going to move them out here so I can see my diagram a bit more clearly. I'm also going to remove the waves, okay, so I can see the triangles more clearly. So I want to find out what h is. Now you've probably seen this kind of question before, where we can solve it using just SOHCAHTOA, setting up some systems of equations, because after all we do have a right angle triangle here and we have one over here. We could probably get information from both of them and solve for h. But I'm going to take a slightly different route, in that I'm going to try to figure out what this hypotenuse is. Okay, the hypotenuse of this triangle here. Okay, because if I have that hypotenuse, I can just use SOHCAHTOA with the angle 33 and the opposite side h, and use maybe sine to find my height. Okay, but I have to get that hypotenuse first. So I'm going to focus right now on getting this side using this triangle here, which is not a right angle triangle. It's an obtuse triangle, and I do have information about it. I have that 20, I have that 31, and I also, let's zoom in here, I also have this angle here, because if you recall, straight line is 180 degrees, so if I do 180 minus 33, that's going to give me 147. 147, let's put that there. Okay, and now I have, well actually, I have even more information, because if that's 147, then I can find that third angle, and that's going to give me what? 180 minus 147 minus 31. That is 47, 57, 77, 80, 78. I think it's going to be, what, 2 degrees, right? So this little guy here is going to be 2 degrees. Very, very small, but, still some angle. Okay, well, now, and let me just maybe make these a bit smaller. Just want to minimize their importance because we were done with that. Now, well, look at this. I have an angle and an opposite side over here. Let me maybe highlight them individually a bit better. Like I said, I have an angle and I have the opposite side of that triangle, okay, of that angle. I can use 31, and let's call this x over here, okay, to solve for the x value using the sine law. Okay, so I can set this up as x over sine 31 degrees equals 20 over, and here I'm going to have sine of 2 degrees. Okay, and that ends up being pretty nice, okay, because I can just solve it. So I get x equals 20 times sine, oh, this is not good, sine 31 all over sine 2 degrees. And we're going to need a calculator to figure this one out. So let's pull that up. I'm going to clear that. And let's just zoom back in here. So I'm going to go 20, well, actually let's do 31 sine times 20 equals that, divided by 2 sine 295. So 295.1, well, I'll just leave it at that, 295 meters. Okay, so we have our x value, which is 295, and now, well, I can use SOHCAHTOA on this triangle to solve for my h value. And if you recall, sine of 33 degrees is going to be h over 295. And I can just rearrange this equation and solve for h. And I get h equals 295 times, oh, this is annoying, times sine of 33. So let's do that. 33 sine times 295. And that gives me 160.7 meters. Great. Looks like we have the height of our cliff using some SOHCAHTOA as well as a sine law.